Use of Michelson interferometer for determining the wavelength of HENE laser, helium neon laser. So formula is 2 multiplied by D dot by M. D is basically the distance moved while we are shifting the fringes. So number of fringes is M basically, and we are taking 20 here. Any you can take it, it depends upon you. So these are the different scales uh, that we will discuss here. First of all, his reason is because we have to find the least count. What is the least count of this scale also and this scale also? Least count is basically the minimum distance on this scale and this scale also. So these are the this is 1 mm, no doubt, but on this scale B and D that we have to measure. So when we give the one complete rotation to C, 100 divisions will move on B. Similarly, if you give the one complete rotation to the wheel E, the number of divisions moving on the this D will be 100. So in this way, so far we will measure least count. So least count of the scale B. One division on the scale A, that was the first scale, divided by 100 division on the scale B. So what is that? 1 mm divided by 100, this one. So least count of scale B is basically what the meaning of least count of scale B means, one division distance of the scale B, this one. Similarly for the scale D, this one division distance on the scale B, this one, divided by 100 division on the scale, because 100 divisions are there on this scale D. So if you divide, this is one division on scale B, that is 0.01 mm, that we already measured, same value we are taking, divided by 100. So answer is 0.0001 mm. Three zeros are there, you can say, and then one is there, that is the least count. So least count of this scale D is one division distance of the scale D. That is the meaning of least count. Further, now this is example only that we have been noted down. So you can see here this one, first scale A. The line blue, you can this line. So blue I have indicated, that is between 1 and 2. 2 is not complete. So whatever the complete is there, that we will note down. This is 1. Similarly here, this part, this line. This line is basically blue line. So this is in between, this is basically 30, and this is 25, 26, 27. This is between 26 and 27, me 26. Whatever complete is there. Similarly here, third scale, this one. Third scale is 90, 95, 94, 93. Right? And so 90, this is 85, 84, 83. Sorry. So 83 we will take. So 83 multiplied by least count here. Similarly 26 multiplied by least count. So multiply this one also, and add all three. That will be the reading. That is the example only. That is the example only to know how to measure the reading. Now this is a picture of this Michelson interferometer from one side. So briefly, you can see this is HEN laser. This is a beam separator. Then the half silvered glass plate is there. Then the compensatory glass plate is there. These are the two mirrors. One is fixed and one is movable. So now briefly I will say compensatory glass plates we have introduced, because when the light is coming on this side, right, it travels through this one twice, while beam going on this side we travel through this glass plate once only. So to compensate the distance traveled, we have introduced the compensatory glass plate. You can see now this is a picture from other side of the Michelson interferometer. This is same thing. This is laser. This is a beam splitter. Now these scales can be, you can see this one also, and this is also scale. Not seen very clearly, but this is scale. So you can see here now. Here it will be the screen where the image will be formed, right? Beam traveling from this side also, they will match on the screen. How they are matching we will discuss later on. This is least count of the scale D also, this one, and this is the least count of the scale B also. D we will move to see the shift in the fringes. Now, when this beam splitter is not in the path of the beam, so what we will see? We will see here two bright spots are there and many other spots are there. Only two bright spots that we will consider. We will try to match these two bright spots with the help of these screws also and these screws also. Means screws behind these mirrors. We will try to move. So one precaution is there: don't stand by putting weight on the table, because this is very sensitive. Because whenever you move, this will move. So don't touch this table or instrument. This is the precaution. So otherwise also we are seeing the many sports also. This one. Those are we are not considering. Those are due to many reasons, not one reason. Maybe multiple reflections are there. That can be by any reason. So what will happen after matching these two screws, these spots, when they are matched, then we will put this beam splitter in the path. What will happen? The fringes, we will see the fringes on the screen. The moment the fringes are seen, we will move this scale, this one, so that the fringes are moving. How they are moving? So first of all, without moving, we will measure the reading. Then after shifting the fringes, then we will measure the reading. So two readings are there. Without moving, initial reading is there, and after shifting the fringes, final reading is there. So what is that? So this one. This is the video basically that you can see. You can see here fringes are falling inside. So these are 20 we will count. You can see this screws we are rotating. So initial reading was without moving these fringes. Then after moving, I have counted 20. You may count 30, 40, 50. Accordingly, the value of M we will change. So that is the basically initial reading. You can see here now this is the zero value, right? So reading will be 0. Now second, this is scale is there, right? You can see here now this is between this line. This is between 18 and 19. This is basically 18, 19. Only complete we will take. So 18 complete here. Similarly here now you can see the reading is there. This is basically because 0 and 100 are same. This is 90, right? So 90, 98 you can say. So because this is 0 and 100 same. So we are on this side of this scale. That's why 1898. If this is after 0, it will be 1, 2, 3. This is 99, 98 in this way. So we will multiply 18 multiply by the least count, because this is 18, because between the 18 and 19. This is 19 basically. This is 18. So this is not complete. 19 is not complete. That's why I'm taking. Similarly, 98 here, multiply by the least count. Multiply these two also. This also. This part also. Then add all three. Answer will be 0.1898. Now that is the initial reading. So after shifting the fringes, that is final reading. So you can see here now. Again, 0 is there, matching with the 0 line. So this one is basically between 19 and 20. Because this is 19 and 20. Slightly greater than the 19. Right? So that's why we are taking 19. Multiply by least count here. Now you can see here now. It is 40. 40 multiplied by least count. So multiply this one and this one, this one, this one, and add all three. That will be the answer 0.1941 for this reading. Further, we will note down all the measurements which we have done earlier. So initial reading, final reading. If you subtract final minus initial, this one, that is the 0.0043 mm basically, right? Because this is mm, this is mm, this will be also mm. So further, number of fringes we have shifted 20 only. It depends upon you, whatever the fringes you are shifting. Maybe because larger number of fringes should be shifted, maybe 30, 40, it depends upon you. So wavelength will be 2 multiplied by the final minus initial reading, right? So we have written D here earlier. So 2 multiplied by D divided by M. M is number of fringes shifted. We have 20. So 2 multiplied by this value, this one. 2 multiplied by this value divided by 20. 20 is the fringe shifted, right? So answer will be 430 nanometer. Further, how we will measure the error. Now made value is this one, 430. So percent error is made value minus that value into 100 divided by 100 actual value you can say. Made value minus that value or divided by the that value, or you can say actual value. Multiply by 100. So percentage error is 430 minus 632 multiplied by 100. That is 32% error. So 32% error is there. This error is large. So due to many reasons are there for this one, right? Maybe it's slight tilting is there of the mirrors, right? Because the screws we have to move in such a way that both the mirrors should be exactly perpendicular to the beam. So that sometimes is not there. That's why error is there. Thank you.